This is how I built my electrical wall in my 96 Bluebird Minibird Skoolie conversion. I'm a 30 or so year electrician. I don't have much automotive or 12 volt DC experience, but I am a skilled electrical mechanic and have built everything from houses to high rises. So this is how I did mine. Just I've noticed on all the YouTube videos when I was trying to learn how to do the 12 volt systems for myself, a lot of the descriptions were a little weak in certain areas and didn't give me all the answers to the questions I wanted. So I'm going to try to be in detail about how I built mine and maybe show you a little bit of the rest of the bus in further videos. But for right now, here's my electrical wall. Okay, so we'll start with these blocks down here. These are my negative terminal block and my positive terminal block. And we have wires that go from here to the chassis, from here to the negative posts on the battery, also to the inverter. We have two parallel runs to the inverter. Just the nature of this particular inverter requires two parallel runs to give it the 2,000 watts power that it has. I ran everything in 1/0 marine grade copper. This up here is a device for measuring the watts used and the voltage in this meter up here. So that's the device that does the sensing of that. It also requires a connection to the positive over here. So this is the battery. This is the wire that goes to the battery. So it comes from the battery directly to this shunt. It's called a shunt. And then from the shunt it comes over and hits the main negative bus. And then that bus distributes it, like I said, to the inverter with two wires. These two wires. This wire right here goes up to the fuse panel, and then this wire right here goes to the chassis of the bus. So that's my negative terminal block. My positive terminal block over here. Let's begin up here at the switch. This is the disconnect switch for the 12 volt DC system. This 1/0 red wire goes all the way to the positive post in the battery. This one comes out of the switch down to this 100 amp fuse block right here, and through the 100 amp fuse block comes down and picks up the bus. From the bus we have a positive wire that goes up to the fuse panel, and then we also have two parallel wires over to the inverter. I think that's all we have on that bus right now. It's just those. Okay, so next the fuse panel. So we got the fuse panel here, has the negative wire coming from the negative bus and the positive wire coming from the positive bus. I've run circuits already up these two wires right here. This one goes to the negative terminals and this one goes to the positive fuse terminals. That is for this cable that you see right here that runs down and over and right here. It's this wire right here, which is gonna, my refrigerator goes in this space right here when this is all done, said and done. This chest refrigerator right here will sit in front of all this. I'm not too pleased with this entire cabinet will be blocked by the refrigerator. I'll have to move the refrigerator to access it. And it's also, the ventilation is slightly limited for the inverter, but I believe with this open hole down to here that I'll have enough. It's not optimum, but it's just with the space requirements with my refrigerator and where I wanted everything to be. So again, there we are on the 12 volt side. Let's see where we leave out the fuse block. So these wires here, the one's for the refrigerator, one to the negative terminal, and then one to the fuse terminal right here. These other 8 wires you see all run up to this terminal, which runs to certain lights in the bus, the cabin lights as well as some external lights I have wired up to this terminal block, which come via switches that I've installed temporarily on this board right here. This board is just temporary until I build the cabinet and the cabinet door for this enclosure. So it just houses the meter for me for now, and a couple of switches just for the outside lights and the inside lights. All my lighting is done via chassis as the negative connection. So I only have to take one wire out to the light, and then the other wire off the light connects directly to the chassis. The refrigerator is the only thing I had that has an actual negative connection at the terminal block. So that's the DC side. See the other side of the wall here. Down here is my 100 amp hour lithium ion battery, which I won't go into all the details of why, but read about it, look it up. It's worth the money. It's an expensive battery. That's a $900 battery, but the benefits of the lithium ion are pretty outrageous. So I would go with that if you can afford it. I plan on having 2, maybe 3 of those. This is a temporary charger that a friend gave me that was just sitting there doing nothing, and so I can charge my battery. It's not the optimum one for the battery, which I'll be purchasing later, but I haven't purchased it yet. And then on up here is my AC side. Right there's my AC panel. I've got 5 circuits. I ran a circuit to each outlet. There's one here, there's one down there on the white wall, and then one at the end of the bus, and then there's another one in this cabinet right here that the computer's all plugged into. Each of those double pole or double outlet boxes is its own circuit. And then there's another circuit. This is a circuit down here, which is what I plug the, what do I plug in here? The refrigerator's, the refrigerator's dual voltage, AC and DC, so I can plug it into here if I'm running off of shore power. Which, in order to run off of shore power, I just unplug this cord right here out of my inverter and plug it into an extension cord and run it to shore power. Eventually I'll have an outdoor receptacle wired in, so it's a little bit more finished. But right now this is just easy enough. Unplug that, plug the extension cord into there, and I'm feeding my panel. My panel feeds off of this cord, so whether it's plugged into inverter or shore power is how that works. This box right here will mount on this wall once I get the finish wall on. It's going to be furred out so you don't see all these screws. And then the shop vac will mount underneath the panel, and then the outlet will be here to plug the shop vac into, or the AC side of the refrigerator when I'm running on shore power, so I don't deplete the battery. The refrigerator automatically chooses the 120 over the 12 volt based on what's available. Anything else? I think that about covers the whole kit and caboodle electrically. Put any questions in the question box and maybe I'll answer them, maybe I won't. Sometimes I get around to it, sometimes I don't. But thank you for watching, and I hope this was helpful to you.